Alright guys, I just wanted to go through these notes with you. This is a free body diagrams. Let's see. So we're supposed to copy down everything that's in yellow. I'm on slide 1. And let's see, where are we stopping? Slides 1 through 17. So yeah, this is actually one of my most favorite subjects in physics because you're drawing real items and you're making a diagram. And so that's the diagram part. What is a free body? Well, if you have, if we do a quick little example, this is like a ball. You got gravity, and if it's sitting on something, we're gonna have a normal force. So this thing could be on the ground because it has a normal force, but we're not drawing the ground, so it's kind of just in the air. It's a free body, right? But it's being supported by this normal force, which you guys have to know what a normal force is. So I think we'll get to that in a minute. But yeah, that's where free body comes from, because it's kind of just floating in the air, but everything that's acting on the ball is a force, right? So we're drawing forces now, another exciting thing. All right, so here's our objectives. We're going to identify normal forces. We're going to draw free body diagrams. With vertical and horizontal, with forces in vertical and horizontal for directions. We're also going to calculate the net force. We're not going to calculate the net force today, so we'll skip that. But this is our objective for today. We're just going to draw these things. Net force we'll get to next time. Let me see some physics terms. Net force, normal force, free body diagram. So yeah, get to those. So here's a nice little definition of free body diagrams. They are tools for figuring out the magnitudes and directions of the forces that act on an object. All right. Hopefully this doesn't. So that's the whole purpose, right? We're gonna look at objects. So like this could be a car, it could be a house, it could be a building. Almost anything that an engineer designs, he has to come up with a free body diagram showing the forces on the objects. And so it says all contacts with the object are replaced by the forces exerted on the object. Forces are drawn as arrows. Okay, so this is where we're going to go through the steps. And so you're going to have your free body diagram on this side and the real object on this side. So let's do that. So give yourself a little space. So this is a free body diagram. Give yourself a little space for some arrows around here. So free body diagram. And then over here, we're going to have the real object. So let's draw it here. So this is the real object. So we got like some crazy contraption. We got a spring, and it's on the ceiling. And this thing is also on the ground. This has a force of 50 newtons going up. And then the mass of this thing is 10 kilograms. All right. So this is what's happening in real life, and then this is like the engineer's drawing. And what we have to do is we have to figure out the forces on this thing. What forces are acting on this object in real life? Well, we got a spring holding it up with 50 newtons. We have some type of weight coming down. We're going to have to figure out the weight of this. This is some type of dumbbell. But this is the real object. So we're going to go, I think there's really only 4 steps that we have to follow. So here's step number 1. Start a free body diagram by drawing an outline of the object. Step number 1. Step 1. Draw an outline of the object. All right, I did that. All right, step number 2. Draw the forces acting on the object. Start with weight. So we're going to draw the force of weight. So every object is going to have a a weight, and it's usually acting at the center of the object. So here's my weight. So this is FW. Should have made some space for that. FW. So we're going to have a weight. So this is the weight of the dumbbell. It's mass times gravity. FW. Alright. Next will be the applied forces. Alright, so who's pushing or pulling on the object? And you could put these where they are acting upon the object. Applied forces are drawn at the point where they act. It's action. And in the correct direction. So what's going on here now? So we got the weight. So next is the applied force. So who's pushing or pulling on this real object? Well, we got this spring pulling up. So we're going to draw that. So that's the force applied. And this is the 50 newtons. All right. So next, step 4. We're going to draw the support forces, but here they word it like this. Surfaces that contact the object. Exert a normal or support force. And usually this is Fn, normal force. So yeah, normal force. So where is this contacting? Where is this dumbbell being contacted by the ground? So really it's there. So here and here, right? So this is where the ground is supporting the dumbbell. So we're going to have force there. So gravity is going down. If it's a support force, it's going up. So these are Fn. So there's two of them. Fn, Fn. Yeah, so every object is going to have a variation of these. Any object with mass is going to have a weight coming down. Then you could draw the applied forces, the ones that are pushing or pulling on the object. And then we have support forces, wherever the object is in contact with a surface, a ground, or a wall or something. Let's see what's next. That's slide 12. Oh, this is a good note. Surfaces always push, never pull. So that tells you the direction of the arrow. Never pull. That's slide 13. Alright. So now we're just getting into the what normal actually means. Let's see. Let's see, normal. So normal usually means like, oh, it's the average. Yeah, that's normal behavior, right? But in math and in physics, normal means perpendicular. Normal forces always point at right angles to the surface. So, and they have a diagram here. They have the weight again. And they have the ground. So here they're just saying that your arrow of Fn is 90 degrees from the surface, right? We've got two of them. 90 degrees. So in when you start getting into more difficult physics classes, you might have something that looks like this. We get into ramps, and maybe you have a box. So the normal force is 90 degrees from here, right? 90 degrees. And that's actually, you don't really need to know this because we're not going to get into it, but if this was an angle of some type, so the angle between here and here, it's funny how this works, is this angle. So that gets into trig, but so we're not really worrying about that. But we do want to know about the 90 degrees. Right? That's a right angle. Sorry for the shadow here. Let's see, that's slide 14. Alright. And then this is kind of a good drawing here. Let's see. Every contact with the surface creates a normal force. So then let's just draw what they mean. So here's the real object. And then this will be the free body diagram. So if we have a ball sitting on a surface here, Now, free body diagram is going to look like this. And so it's contacting the surface there. So we're going to have a normal force there. And then we're also going to have the weight coming down. Right? It's not in the slide, but yes, you will have weight because it is an object. So we have weight coming down and the normal force going up. Now then we have a more complicated example. We have a ball. And then we have it wall coming down and a ramp. Alright, so what does this one look like? Well, we have a ball. And we're going to have the weight. But we're going to have the normal forces. There's one from the ramp, perpendicular. And remember, they always push. Then the wall is also hitting it there. And that's it. That's it for the notes. So yeah, so you can get into a lot of cool examples like this where we have to figure out the forces and stuff. Most of the time we're dealing with simple ones in this class because we're just algebra based. We're not using trig. So we'd have to use trigonometry for these. So that's one good thing. So get these notes down, submit them, and that'll be your grade. Thanks a lot.